Section 3.4 is going to ask us to prove trigonometric identities. We're going to start, like I said, with a little bit of a review here, and that is by looking at the sine and cosine of positive and negative angles. Now, the cosine of an angle was its x-coordinate on the unit circle. The sine was its y-coordinate on the unit circle. And let's start by looking at the sine of theta. So that's going to be this point here. And compare that to the sine of negative theta. Well, if you go the opposite direction, then what's going to happen to the value of sine? It becomes negative. So sine of negative theta is the same thing as negative sine of theta. But how about cosine? What's going to happen with the cosine? Cosine's not going to change, right? If you go a positive theta or a negative theta, cosine of negative theta is equal to cosine of theta. You're at the same x-coordinate. So it doesn't make a difference which order you go. So let's fill that in here. Cosine of negative theta is the cosine of theta. That makes cosine what's called an even function. It's even because its graph is symmetric, just like the graph of y equals x squared. So there's our cosine function. If you look at it, it's even with symmetric, or even with respect to the y-axis. It's symmetric around that. Okay, so this cosine was an even function. Let's take a look at the sine while we have the graph here. So I'll ditch that. Let's do y equals sine of x. Is sine an even function? No, because it's not a reflection of itself around the y-axis. Sine is an odd function. So that's why they call this the even-odd identities. This is an odd function. This one's an even function. Now, once you know those two basic identities, you can start proving other identities. For instance, the tangent of negative theta. Well, tangent of negative theta is the sine of negative theta over the cosine of negative theta. Sine of negative theta I already know. That's just negative sine of theta. Cosine, that's an even function, so cosine of negative theta is cosine of theta. Can anyone rewrite this one last time? What could I write here? Negative tangent of theta. Right? Because that's your tangent of theta. You still have a negative out there, so negative tangent of theta. Yay. Why don't you see if you can't do something similar with the cotangent of theta? See if you can't work out an identity for the cotangent. Shamir, cotangent is what over what in terms of our basic trig functions? Good. So this would be cosine of negative theta over sine of negative theta. Good. Where can I go from there? All right, good. Cosine of theta over negative sine of theta. Does that simplify any farther? Yeah, negative cotangent of theta. So both of these are, again, odd functions because that negative seems to kind of sort of factor itself out here. We can finish this up. For secant of theta, this is going to be 1 over cosine of theta. But 1 over cosine of theta, Michael, has another name, right? What's 1 over cosine of theta? Yeah, secant of theta. Thank you. You can do likewise for cosecant of theta. Any predictions? What's cosecant of negative theta going to be? Negative cosecant. Negative cosecant of theta. Nice. So kind of as a summary, sine of negative theta was negative sine of theta. Cosine was nice and even. Tangent, the negative came out front. Same with its reciprocal, negative cotangent of theta. Secant of theta and cosine of theta are the only ones that don't change. So secant of theta and negative cosecant. Yeah, negative cosecant of theta. So there's kind of your overall summary. But once you had these two, you're able to derive the rest of these. We kind of proved these. So this is a little baby step introduction towards proving identities. And we're going to use that as kind of the basis for our first example in proving identities. There was some talk before class, if you weren't here, that's fine, about, well, can't we only work with one side? There are certain problems that you only work with one side. And proving identities is those kind of problems. So what do I mean here? Let's take a look at problem number 22. Problem 22 asks you to prove this identity. That is 1 plus cotangent squared of negative theta equals cosecant squared of theta. And one of the things I'm always going to suggest to you, whenever you're working with an identity that has some squared terms, let's go back and think about the Pythagorean theorem. What does the Pythagorean theorem say? What's the most basic form of the Pythagorean theorem? All right, sine squared theta plus cosine squared theta equals 1. Now let's look at this here a little bit. Look at the cotangent squared of theta. What trig function's in the denominator of the cotangent? Sine. So how about if I take this Pythagorean theorem over here and divide everything through by sine of theta? Actually, by sine squared of theta, really. And simplify that. Don't just leave it like it is. Simplify it. You coming up with an answer, or do you have a question? All right. Let me spread the wealth a little bit. Mavis. How's that simplify? All right, so it'll be a 1 here. Plus what? Cosine squared over sine squared reduces to, or it can be written as what? Cotangent squared, good, equals cosecant squared, right? So this doesn't look too far away from this, but I still have to prove that that's true. All right, now I can only work with one side. And in a little bit, I'll write down some general kind of steps or rules for you here. But if you're only going to work with one side, I generally suggest you work with the more complicated side. Which side looks more complicated at the moment? The left-hand side. All right, so let's work with the left-hand side. And here, let's understand some notation. This notation really means cotangent of negative theta quantity squared. So it really just means you're squaring the whole thing. That little square here trick, it's nice, it's convenient, it's more compact than writing it like this, but they mean the same thing. What can I do from here? Still working on the left-hand side. Any suggestions? Yeah. let's factor out that negative, right? I mean, that's what we just did. That was kind of what prompted that whole handout there. So I'll factor out the negative. Okay. Does this simplify? I'm not looking for cosine over sine. Yeah. If you're squaring out a negative times a negative gives you positive. So do I need the negative in here? No, I don't. So I could write that as 1 plus cotangent of theta quantity squared. Because if I'm squaring negative 6 or positive 6, either way, I'm going to get 36. When you square it, the negative sign is going to disappear. So let's just get rid of the negative. And there's one last step. That one last step is to go back to this kind of notation. In fact, this and this are the same. And here I can stop. Well, if you wanted to go down to here, cosecant squared of theta, that's fine too. But you're going to keep going until the left-hand side and the right-hand side are equal, but you've only manipulated one side. And that's going to be the toughest challenge for you in working with these things, is to only work with one side. How are we looking on 22 there? Go for the more complicated side, generally speaking. Now these, the tough thing about these problems is that there's no one approach that's going to work for all of them. So you're going to have to kind of think a little bit on each and every one. I'm going to try and give you as many examples of different things as I can. But at some point, you're going to need to start trying some things. Yeah. Here, that's this identity. These two are the same. 1 plus cotangent squared of theta is the same thing as cosecant squared of theta. So I can replace this by this. Okay. Anything else? Thanks for the question. Brittany?
It's going to be kind of a stupid question, but I'm going to ask it.
It'd be stupid if you didn't ask it, so thanks for asking.
So where it's like 1 plus and then like in parentheses, cotangent, no, next one down.
Mm-hmm.
So like I get everything, and then once you get to there, like the squared is still outside
Right.
of both of those in the parentheses. So how are you just getting cotangent squared and not theta squared?
Well, this is just different notation. It's just a different way to write the same thing. This notation means this.
Okay.
So it's,
I don't need to overthink that. Just know that that is what that means.
yeah, it's just like I could write x to the 1/2 or the square root of x. They're different notations, but they mean the same thing.
Okay.
And that's yeah.
Thank you.
Only if you know how much people in calculus struggle with this.
Yeah. You know,
For the derivation and
So
Yeah.
is it like that because theta's in its own little parentheses?
it's just an accepted way to write this. What this means is this, or cotangent of theta times cotangent of theta. You're not squaring what's in the parentheses.
Right.
You're squaring the whole function.
Okay.
Yeah. So, trying to think, just to go over an example here. For example, if I had cosine of pi over 3 squared, I could also write that as cosine squared of pi over 3. Under no circumstances does it mean the cosine of pi squared over 9. That's something much different. What this means, if you write it this way or you write it this way, means cosine of pi over 3 times cosine of pi over 3. And the cosine of pi over 3 is 1/2 times 1/2 is 1/4. If you evaluated it here, another way you could do that would be to say, okay, well that's 1/2, and then I square 1/2, and I again get 1/4. But if you try and do this, I have no idea what you're going to get, but it's not going to be 1/4.
I wasn't thinking of it like in terms of like squaring the pi and understanding since like the theta was also in parentheses, but I get it.
Okay, that's good. No, I did. Yeah, I didn't think you were confusing, this with this, but I'm just kind of illustrating this. What it means is that you're gonna, if you start out with this, it really means this. Square what's inside, get 1/4. Okay, thanks for the question. I do appreciate it. Let me give you some general guidelines. Now I got to emphasize these are general. Now, have I played this experiment with you guys where I asked you to think about something that you're good at? No? Have not. Everyone's got a talent, something that you're good at. So I want you to think about something that you're good at. I'm sure you found something. Now let me ask you a question. How did you get good at your special talent? Practice. Is there any other way you're going to get really good at something?
Talent.
I think talent only takes you so far. There has to be some practice. I mean, there's not too many people that can just do it just because they're gifted. So, I think even they practice. General guidelines. All right. There's definitely some natural gifts, but natural gifts without a little bit of sweat equity is not going to get you too far. All right, so some general guidelines for proving, for proofs. And again, you can only work with one side. If you start working with two sides, that's it. You're going to make my job of grading really easy. I appreciate it. But let's try and get you all the points. So one thing you can try is write everything in terms of sines and cosines. Sometimes that'll help you to see, oh, here's what we can do here. Sometimes it's one step on the way. Sometimes after you write everything in terms of sines and cosines, you might see, oh, hey, wait a minute. I can factor out a GCF, a greatest common factor. Yeah, okay, that might be true. What else? If there are squared terms, and by that I mean cosine squared, sine squared, tangent squared, secant squared, etc. If there are squared terms, use a version of the Pythagorean theorem. Now there's a bunch of versions. If you notice what we did in the last problem, problem number 22, I figured out what I needed, and then I figured out the identity that went along with it. I needed an identity that had a sine squared in the denominator, so I divided everything through by sine squared. What else? Sometimes you want to get a common denominator. If you can bring two things together, great. Try that. You can try multiply by the conjugate. Multiply by the conjugate. And let me remind you of what the conjugate is. The conjugate is when you're dealing with binomials. So you could have one binomial is a plus b. So this is a binomial. Its conjugate, anyone? A minus b. You're just going to change the sign. If you had a minus b, the conjugate would be a plus b. But when you multiply these together, you're going to get a squared minus b squared, and you're starting to get towards the Pythagorean theorem or some versions of it. So that's why that helps out sometimes. Again, these are things to try. Let's see. Other suggestions. Clear out the denominators complex fraction. Sometimes you'll have fractions within fractions, so clear out the denominators of the complex part. What side in general do I suggest you work with? Yeah. Yeah, the more complex side or the harder side. Okay, so try something. I mean, just, it may not work. And if after a little bit you're not seeing some progress, try something else. But try something. Okay, so let's give a few of these a shot. There's a lot of different tricks that I'd like to give you examples of. May not be able to do every last trick, but I'm going to try and hit some of the important ones.
We used to say these guidelines. I remember the last one was do something.
Yeah, do something. Actually, in my notes here, here's the last guideline. Bribe me. All right. All right. Yeah, I know. There's a reason I don't like to put that on the video recording, because people actually think I'm serious or something. All right. So let's try problem number 28. What's that? I'm not. I'm sorry. I'd probably be rich for a semester, but then I get fired, and that wouldn't help me out in the long run.
Theoretically, how much money would it take?
Theoretically, no. I'll tell you very practically how much money it'd have to take. Enough that I could retire on. So comfortably retire on.
Years left of salary, so that's probably
Oh, only 10? You're dating me. Huh, I'm wounded.
$50,000.
Your grade is going south here. Only 10? Do I hear 15? 15, 20, 20, 25? 40. All right. A plus there. Good job. Oh, okay. Good save. Good save. All right. So let's try a few here. Do I have problem 28 right? It's cosecant of theta minus 1 times cosecant theta plus 1 equals, is that 28. Let me just get to, yes, I do have that one right. All right, so let me copy that down. Cosecant of theta minus 1 times cosecant of theta plus 1, and that's equal to the cotangent squared of theta. All right. Well, what side do you want to work with? I'm thinking the left side looks a little bit easier. Sure. You could actually, I mean, theoretically you could work with either side, but let's work with the left-hand side. Is there anything you think we can do with the left-hand side? Multiply, divide.
Couldn't you just put it all together and just square it?
All right. Suppose you FOILed this out. Cosecant of theta times cosecant of theta. Long distance dedication to Brittany here. That's cosecant squared of theta. All right. Plus cosecant of theta minus cosecant of theta minus 1. Now you're still just working with the left-hand side. Is there anything that we can do here? Hasta la vista. So it's cosecant squared of theta minus 1. Still just working with the left-hand side. Now, I've been teaching this course since 19 mumble mumble, and I don't have all the versions of the Pythagorean theorem memorized. Let's just think about cosecant squared of theta. What's the denominator of cosecant squared? Sine. So let's take the Pythagorean theorem and divide it through by sine squared of theta. sine squared of theta. Hans, how is this going to simplify? Sure. All right, thank you. And if I move the 1 to the right-hand side, Rebecca, what's this identity become? Perfect. So what can I write here then on the left-hand side? Cotangent squared of theta. And there you go. So we worked exclusively with the left-hand side. And we eventually showed that, gee, okay, as strange as that looked initially, these two things are actually equal. So good on us. We got it right. Now, I would tell you this. I will not give you one that doesn't work out. If I give you an identity to prove, you can prove it. Period. I'm not going to trick you on that. These are hard enough. I wouldn't do that to you, okay? All right. Any other thoughts on problem 28 before we do some more? So we used a couple things here, a couple of our identity or our ideas here. It was really kind of number 5. We multiplied by a conjugate, all right? So we used that a little bit. And we used number 1 too. No, actually not number 1, number 3. So I'd say we used number 3 and number 5. Both of those ideas were helpful. There's a squared terms, use a version of the Pythagorean theorem. And the multiply by the conjugate was kind of already there. So my goal is to try and give you examples of a lot of the stuff that I outlined there. Onward. Problem number 34. Tangent squared of theta times cosine squared of theta plus cotangent squared of theta times sine squared of theta equals 1. I see a lot of squared terms here, but I'm not sure that turning everything into a Pythagorean theorem is the right choice right now. Are there any other ideas that are springing to your head? Good? Yeah. So look at this. You write it in terms of sines and cosines, and wow. These terms disappear pretty quickly. So what are we left with on the left-hand side? Yeah. Sine squared of theta plus cosine squared of theta. And that's 1. So there you go. 1 equals 1. Nice. Now, when you get home, you're going to find out just how easy I'm making these things look. They're not easy. They are not easy. They're going to take practice. You're going to get frustrated. You're going to take a mod's name in vain several times, and then you're going to get back and work on these things. But they're challenging. They are.
At home, you're smoking a cigarette, probably smoking something else.
Yeah. Hey, it's legal in Huntington Woods now, so you're okay.
Relax.
All right. All right. However you want to get the creative juices flowing, that's up to you. Let's try problem number 36 here. Cosecant to the 4th of theta minus cosecant squared of theta equals cotangent to the 4th of theta plus cotangent squared of theta. I gotta admit, I remember this class very clearly from being an undergrad and looking at some of these things and just going, no way. It's just not possible. That's such a strange looking relationship. How on earth could that be true? But what did I promise you a little bit ago?
You're always going to give us ones that we
Yeah, I'm not going to give you something that doesn't work out. I am not going to give you something that you can't prove. Okay? So if I'm giving you an identity, that means there is a proof. So put that part out of your head, and if you can get past that, then we can make some progress. Now, your choice. What side do you want to work with? Right side? Okay. It really doesn't make a whole lot of difference, I don't think. So let's see if we can't work with the right-hand side. All right. What would you do on the right-hand side? What could we do there? All right, good. Factor out a cotangent squared of theta. That's going to leave behind cotangent squared of theta plus 1. Okay. Now what? All right. But you guys, it's a good start. It's a good start, and it's the right thing. So we'll look at your list. All right, terms of sines and cosine, that's one possibility. I'm going to kind of guide it, so let me veto that, though. Pythagorean theorem. Let's think about the Pythagorean theorem here, right? So we're back to a cotangent. Look, we just did that one, so I'm not going to do it all over again. I'm hoping you get the idea about cotangent, sine, cosine, etc. So what did we end up with? We ended up with 1 plus cotangent squared of theta equals, oh, look at this, cosecant squared of theta. Isn't that promising? In fact, let's think here. What could I do here? All right, that is going to be a cosecant squared of theta. And, don't make Brenda do all the work here. What could I put in for cotangent squared of theta?
Cosecant.
Cosecant?
Theta.
Almost.
Or minus 1, yeah.
Yeah, so we gotta move that over there. So cotangent squared of theta equals cosecant squared of theta minus 1. So I'm going to put that in parentheses, cosecant squared of theta minus 1. And then what? Yes. Distribute this. If I distribute this, what do we get? Cosecant to the 4th of theta minus cosecant squared of theta. And wow, that's exactly what I have on the left-hand side.
How do you get cotangent? I guess I'm just the whole thing that we just did.
It's the Pythagorean theorem right there. So,
And that's always
you know.
true? Or is that going to be like...
no, that's always true. So, I mean, we derived that back in problem number 28. Here's the actual derivation. If you happen to have that memorized, great. If not, derive it. But, so here, 1 plus cotangent of theta, that's cosecant squared of theta. And then the other thing we had over there was,
I wrote it from like the things from the back of the book that like show the equations, and I was just confused for the identities.
so can you follow the colors a little bit?
Yeah.
Cotangent squared of theta plus 1.
That when you explain it, I don't...
Okay. Okay. Yeah. You know, if you have these memorized, great. But I don't have them memorized. You are going to have a ton of stuff to memorize in this class. And the less that we have to memorize, because we can kind of derive what we need when we need it, the better off you're going to be. I mean, literally, I teach this stuff and I don't have all these memorized. I just don't. Okay. How are we looking on problem 36 there? Is that all right? That's a good idea. So let's see. What do we use in that one? So this one we used factor out a GCF. We also used, there's squared terms used the Pythagorean theorem. So these are the couple of the ideas that we used in this one. So we used 2 and 3. In problem 34, we used number 1. So those are, again, some of the ideas that we're using. Let's try problem number 40. Nine secant squared of theta minus 5 tangent squared of theta equals 5 plus 4 secant squared of theta. What side do you want to work with? Left-hand side? Okay. Any suggestions there? Any places to start? Yeah, maybe eventually, but I'm going to have to maybe try there right now. Well, there's no like terms though.
I'm sorry, but the 4 secant squared and the 9 secant squared, can you, or would that, no, the 9?
Well, we have to work with one side. So it's a good idea, but we have to work on the side.
9 and the 5 first.
What's that?
Get rid of the 9 and the 5 first. Up front, no?
But in terms of getting rid of the 9 and 5, you can't exactly factor them both out because they're not. It's not a common factor. But you're right to focus on the 9 and the 5. Sure, Bill? We could. I don't know. Maybe I can work it a couple different ways. We could factor if you wrote it in terms of sines and cosines, we could eventually factor out a 1 over cosine term. What catches my eye is this. What's 9 minus 5? 4. So, okay. How about if I rewrite this like this? What if I wrote it as 4 secant squared of theta plus 5 secant squared of theta minus 5 tangent squared of theta? You like that idea? Can you see the motivation for it? The 4 secant squared of theta is here, and then I have these terms, but what's nice about those terms? They share a 5, and that's kind of suggestive there, right? What about that 5 that they're sharing can we suggest? Let's factor it out. So I got 4 secant squared of theta plus 5 times secant squared of theta minus tangent squared of theta. Like I said, I promise you, I just don't have all the versions of the Pythagorean theorem memorized. So here's your turn. Write out the Pythagorean theorem, sine squared of theta plus cosine squared of theta equals 1. And see if you can't manipulate it so that you get an identity to use here. See what you can come up with.
Isn't that 1? Sine squared theta minus tan squared theta.
Figure it out. Prove it to yourself. I mean, you could be right. But it's good that you can prove it.
think about it. I can't remember anything with math. Well, because like the body, like I can memorize.
The weekend's fading away. That's good.
Bones and everything, because I can visualize it.
Okay. So if you look at this, the denominator in both these terms is all together? Cosine. All right, good. So I'm going to divide everything through by cosine squared of theta. On the left-hand side, I get tangent squared of theta plus 1 equals secant squared of theta. Now, looking at what I have here, I want secant squared of theta minus tangent squared of theta. So let's take this term and move it to the right-hand side. Now, when it changes sides, what else changes? Sines. And that's S-I-G-N. I get secant squared of theta minus tangent squared of theta equals 1. Wow, isn't that special? 4 secant squared of theta plus 5 times 1 equals, well, that's 4 secant squared of theta plus 5 equals 5 plus 4 secant squared of theta. All right, close enough there. So again, you're using the Pythagorean theorem in these types of problems. So back to number 3 again. Pythagorean theorem is what made that one work. What, the last step here? Or, I mean, I need to see some steps. I get worried about miracle leaps of faith. Say again? Oh, you mean this step? If you were... I will accept the Pythagorean theorem here. You don't have to show that. Although, I mean, you need to know it. You need to at least prove it to yourself as how that works. But you don't have to justify every single use of the Pythagorean theorem. Anything else on number 40? Try a fraction one. All right. Long distance dedication to Brenda, who wants a fraction. Okay. Tell you what, let's do problem 42. Don't have to look too far, right? So problem 42. And I'll do it 2 different ways. 2 different ways. So the first approach, we got 1 minus sine squared of theta over 1 minus cosine of theta. And somehow or another, this is going to equal minus cosine of theta. And again, if you're like me when I took these classes, I looked at it, I'm like, no way. It's just no way. It just doesn't look like it makes sense. I don't know. Was I different than you guys are now? No. You look at that and go, nah, it ain't happening. Okay, all right. Then you're unique. You're special. You're special. Okay, well, let's try an approach that we haven't used yet. Number 4. What did I suggest in number 4? Common denominator, right? So what's a common denominator? Now, I'm assuming we're working with the left-hand side, right? Okay. What's a common denominator for these two? 1 minus cosine of theta. So I'll replace this with 1 minus cosine of theta over 1 minus cosine of theta minus sine squared of theta over 1 minus cosine of theta. Did that get me anywhere? A little bit. Go ahead. What? Okay. So let me bring this together in one numerator first. 1 minus cosine of theta minus sine squared of theta over 1 minus cosine of theta. And you're right. Let's get rid of sine squared of theta. Why are we getting rid of sine squared of theta? All right, because we have something to replace it with. Also, this is in terms of cosine. So if I get rid of the sine squared theta, at least I'll have everything in terms of cosine of theta. And that seems to make sense, that I'll have everything in the same kind of units in some sense. So I'll replace that with the Pythagorean theorem. 1 minus cosine squared of theta. So Vivek, this is where you don't have to prove that, all right? Just use it. I don't want you to prove that. Now what? Now what can I do? Suggestions? All right, let's distribute. That's a great idea. So 1 minus cosine of theta minus 1 plus cosine squared of theta over 1 minus cosine of theta. Yeah. Cosine of theta. Have we gotten anywhere? Does it at least look promising for some reason? What can I do with this step? Cancel out the ones. At least we finally got rid of something. I mean, for a while it seemed like we were getting more and more complicated, but now it seems like it's getting a little bit easier. So it leaves me with minus cosine of theta plus cosine squared of theta over 1 minus cosine of theta. Let's factor out not just cosine, but what else? Factor out negative cosine. So if I factor out negative cosine, what's left behind? Well, if I'm factoring out the negative and the cosine, then I'm left with a positive 1 and a minus cosine of theta. And isn't that special? What comes up now? Cancellation. Hasta la vista, baby. Those cancel. What's that? Woohoo! Can I wait? Say that louder so the mic picks it up. Okay. All right. Good job. Extra credit there. And finally, that's minus cosine of theta. Yay! Minus cosine of theta. As strange as it may seem, bless you. That's what the right-hand side was. It worked out. So this time we did it by getting common denominators. Nice. All your papers. I could dig out my old trig book. I remember feeling euphoric when I finally solved problem number 9. 'Cause I'm like, oh yeah, I get it, yay! I wanted to do a fist pump. All right, let's see. Let's try that again a different way. So this is only just to show you that there's more than one way to do these things. Sine squared of theta. 1 minus cosine of theta equals negative sine of theta. Oh, negative cosine, thank you. Now, I think you had a suggestion last time at the start of this, Vivek. That is, what if we replaced sine squared of theta? You're like, all right, you know what? This is screaming out the Pythagorean theorem. Let's start by using the Pythagorean theorem. So instead of sine squared of theta, I can write that as 1 minus cosine squared of theta, like this. Now I'm still only going to work with the left-hand side. All right. The numerator factors. 1 plus cosine of theta times 1 minus cosine of theta. And that's looking pretty promising. This is a much different way to do this, isn't it? One minus cosine of theta cancels itself out. So I'm left with 1 minus 1 plus cosine of theta. Distribute the negative sign. 1 minus 1 minus cosine of theta. Minus cosine of theta. You know, it's you don't always see the easy route first. I remember one time, this is years ago, but I was solving a problem, and man, I took the wrong approach. It took me like a page and a half. I'm like, there's no way. Finally dawned on me the right way to do it, and it was like 2 lines. Look, everyone's going to struggle on these things. Don't feel bad. Feel bad if you're struggling and you don't get help. Feel bad if you're struggling and you just quit. All right? You just got to work on a lot of these. I'm trying to show you as many examples as I can of how these things work. All right, so let's do another fraction one. Since we're on this fraction kick, let's do another one. See what you started? All right. It's all right. Yeah, please. So what we did is we factored this. Essentially, we regarded the numerator as being a special case of a squared minus b squared. That factors into a minus b times a plus b. So my a is 1, my b is cosine of theta. Because I got 1 squared minus cosine squared. I've had the difference of 2 squares. So that's the idea that I'm using there. So, no, thanks for the chance to clear that up a little bit, because I'm sure you weren't the only one that struggled with that. Anything else on 42 before I move on? I mean, I think everyone, myself included, likes the second method better. But, you know, both of these things work. I mean, sometimes you're going to have to find a common denominator. Let's try problem number 44. 44, cosecant of v minus 1 over cosecant of v plus 1 equals 1 minus sine of v over 1 plus sine of v. This is another one that it just doesn't really look possible. But we've done a bunch of these. Look back at your list of things to try. Any ideas?
What side are we
It's up to you. What side do you want to work with?
I would think the left.
The left? Yeah, I would probably go with the left because a cosecant seems more involved than a sine. Okay. Jeff, any ideas? All right, let's turn it into terms of sine. So 1 over sine of v minus 1 over 1 over sine of v plus 1. Okay. What you have now is called a complex fraction. You have fractions within fractions. It's a fraction hater's nightmare, all right? But we can work with this. How do you work with something like this? Yeah, the trick is to multiply everything, all 4 parts of these, by the lowest common denominator of the secondary fractions. Now your secondary fractions, that's these, here and here. And the LCD of those secondary fractions is just sine of v. So sine of v over sine of v. So what has to happen? Don't cancel these. I don't want to cancel the sine of v's. What should I do instead? What I want to do is I want to distribute, right? Well, let's see. It's going to be sine of v over sine of v. So what's, if I distribute, I get sine of v over sine of v. What's another way to write sine of v over sine of v? 1 minus sine of v over 1 plus sine of v. Wow, look at that. Faster than Donald Trump can create controversy? You got your answer. So, all right, that's it. All done. Just really one line, right? Just had to clear out the complex fractions. You want to try one? So this is kind of an example of number 1, and what else would you do? So we wrote everything in terms of sine and cosine, and that was number 6. Number 6, complex fractions. So it's 1 and 6. So you're seeing a lot of different ideas as we go through these things. Now, it's going to vary from problem to problem as to what's going to work best. Let's go up here for problem number 58. Sine of theta, cosine of theta over cosine squared of theta minus sine squared of theta equals tangent of theta over 1 minus tangent squared of theta. All right. Let me encourage you to work with a particular side. But out of curiosity, what side do you think you want to work with, right or the left? Right. The right. I'd go with the right. And what are you going to do with the right-hand side? Is any idea? Sine of theta over cosine of theta over 1 minus sine squared theta over cosine squared of theta. All right, give that one a shot. See if you can't come up with it. about that last week? Oh, that's right. That's right. It's a hockey injury. Somebody aggressively attacked my elbow with their ribs repeatedly.
Somebody in the face.
Oh, the elbow, yeah. Elbow. No, that was the week before. People keep on attacking my elbow. I don't know why.
They know it's your 1 week.
It's my Achilles heel. That's right. Okay. So the trick here is to get rid of the complex fraction. So you have to look at the denominators of our secondary fractions. So this is a secondary fraction. This is a secondary fraction. If you look at those denominators here and here, what's the LCD? Albie? Cosine squared of theta. So the trick is we're going to multiply by cosine squared of theta over cosine squared of theta. Now when we do that in the numerator, you think of that as over 1 if you'd like. In the numerator, one of these will cancel with one of those. I'll be left with cosine of theta times sine of theta. Cosine of theta times sine of theta. In the denominator, if I distribute that, cosine of theta squared minus, when this multiplies this, what's going to happen? Cancels out. You're going to be left with minus sine squared of theta. Right? So, is that pretty much it? If you look back, that's, I mean, other than rewriting it as sine of theta times cosine of theta, which I'm not going to make you do, that's it. So, wow, it was just really one step, right?
You know what happened to me? The 10, I put sine over cosine at the beginning, but I didn't put the cosine the second step, and I just ended up wrong. I put sine over 10, 11 cosine.
All right. I think here's a good place for a break. I'd love to do more, but at some point you're just going to have to practice these on your own. For homework, try 19 through 69. All right, I'll see you in 10 minutes.